Hi, I'm Bruce. For once, I'm not giving my kernel talk or directly about containers and meta-virtualization. So I am going to broaden my horizons and everybody else's and talk about some of these modern languages in Open Embedded and Yocto. And you see my title, there is no magic. What there is re-implementations behind the scenes of the same fetchers through custom choke points of proxies and registries implementation in the background, and that's the magic. So that is what I am going to attempt to talk a little bit. So I'm going to talk about some of the issues with modern languages and what they do, just a sort of a general overview, some of the requirements and constraints that we have to fit within the Yocto project and open embedded frameworks. If we just went wild, it would be pretty easy to let some of these things just go and do what they needed to get a build that worked once. I'm going to go over some of the different approaches to solve the issues around the modern languages and how they fetch their dependencies. I'll give a quick specific language example, which would be Go in this case, and then quickly hit on some future work. This talk shouldn't actually, I don't think it'll run the full half hour, because I think maybe there might be some questions or some comments at the end. So there'll be time. I left it time for that. Plus, I didn't want to write any more slides. So some things to know that I am talking about the challenges, the requirements, and the options. And like I have in the slide here, to engage and generate some discussion around this. I am not trying to solve all the problems or critique any of the existing approaches. I am not an expert in most or any of the languages in this talk. So I'm not your guy to dive into the guts of any one in particular of the languages. These topics have been discussed multiple times on the mailing lists and in person over multiple years with many different participants, maybe almost as often as how do I submit a patch, and man, I wish I had a layer setup tool. So I'm not trying to simply summarize those discussions. This is just the current state of where we are based on a little bit of things that have been discussed in the past. And in particular, some of the languages have actually evolved underneath us while we've been talking about doing this. In particular, Go seems to change its mind quite often. Whoops. All right. So to summarize the problem, it's that many of the new, modern languages, I think everything newer than C is a new language to some of us, but anyway, they have built-in or language-specific dependency management and tools associated with that dependency management, right? There's and the different, in my opinion, in particular, that the tools and the underpinnings of how they're managing those dependencies, they're not widely understood by recipe creators. That's me, and I don't think they really should need to be. So balancing that, how to integrate with those backends and what to expose to a recipe is one of the challenges. And the integration of some of the languages with the Yocto project's features can be challenging, or at least tricky, or at least something to keep in mind, because we're talking about a lot more than just fetching the source, putting it in the right place, and then building it. There's all of the integration with everything from licensing to offline builds to reproducible builds to SBOM, you name it. If you don't have that integrated properly, then there's going to be gaps in the implementation. Another thing is that the solutions must be maintainable, meaning how we integrate with the language's dependency management must be tested. It must have self-tests in the tree. It must be able to evolve with the language as they change their mind and change some of the settings. It must be something we can override and work with. So there's a whole it's more than it works for one recipe and one build and one case. We don't want to fight the language or the upstream of that language, if you will, in the sense of we don't want to re-implement everything, but we're also often more interested in the specification about how those dependencies are found, fetched, and managed versus the actual tools that do it, because that gives us the opportunity to do an implementation into open embedded versus just wrapping some of the tools and hence hiding the magic and not understanding the magic and then dealing with really nasty problems that we don't understand. And I consider this somewhat like the BitBake open embedded interactions with the various build systems that we've had to wrap over the years, whether it be Ninja, Meson, Auto Tools, you name it. So in the sense of we need to work with and be able to set the variables and the environment around the languages such that they will fully integrate and be somewhat transparent to the recipe creator within the OE build. So a few of the questions or concerns or things to keep in mind when solving these languages are scalability and performance. We've talked about this on the mailing list. It's, there's quite literally thousands of dependencies that pop up for some of the languages. So everything from the BitBake implementation to, through the fetchers and the build need to be able to either scale to thousands of packages or scale to thousands of fetches or lots of IO or, there's all kinds of different concerns around scalability and performance. I put that at the bottom of the pile because make it work first and we can worry about making it work fast after. Recipe clarity is a big thing. You can move the complexity around different parts of a recipe. You can hide it in BB classes. You can hide it in tool scripts somewhere. But in the end, things need to be at least clear, which leads to them being maintainable. A big thing for me is the transparency of the sources that are being built. So if you're doing more than just a one-off build of the application, I want to see where the sources are coming from, where they are in the build. Can I get into the build and poke around and manipulate them and debug and do builds and different things like that. So the transparency of those modules is important, which leads to my next thing, which is, of course, can I debug build problems? Is it maintainable? Does the implementation of fetching of the dependencies lead us to reproducible builds? Are they either checking the host, checking the network, checking something that's changing the layout, which is then changing the resulting binaries? These are things to be aware of. Another thing is long-term support. If we are relying on modules being fetched from some central language repository or proxy or some infrastructure that we don't have a parallel or copies of, it's, will that, if we offer a 5-year LTS or somebody that's building on top of open embedded in Yocto offers 10-year, is there a way that they can do really long-term support? Is it broadly usable, the implementation? What is the developer experience, which is sort of around the debugability I was talking about. And again, the developer workflow. Can you do iterative builds? Can you, can you do external source? Is there ways that you could actually do more than just build it? Can you do some level of development? And of course, licensing and security. You'll see some jokes and some memes around. I've seen some around NPM and Node or whatever, where it's a little bit of installing thousands of potentially untrusted modules and letting them run in a minimal sandbox, right? So the question is, do we know the licenses and do we know the security around all of the modules that are being fetched and built? Those are just a few. There's more. I'm sure there's more. And the requirements around the solution is that many of the answers to those questions require a full and proper integration with the fetcher and related functionality, meaning it needs to meet the constraints of and the implementation hook points that the bitbake fetcher requires in order to get us the licensing and the security and the long-term support. That's a big part of answering those questions. The solution should work for many years, and that we do trust the upstreams, the proxies, and the package repositories. I'm going to summarize, as seen on TV. As seen on the open embedded architecture list, there was a discussion, I don't know what it was, 6 to 8 months ago. I don't know, it comes up every few months, so it all blurs into one when you've been at this for 10 years or more. When somebody was asking, I think it was NPM was potentially, or node was the topic, but, and Richard took the time to write up some of the requirements around what it would need to implement and to integrate with bitbake and OEcore. So I kind of broke them up and summarized them into one of the topics is network, right? Network access is for sources is only expected to happen in do fetch. And then he said, in particular, no access and do unpack, which is a common workaround. I think I pointed out somewhere else that, of course, we've now gone ahead and implemented enforcement of that. Unless you explicitly disable it, you're not going to be allowed to do network access outside of the do fetch task, which is fantastic. The DLDIR, it should be in a suitable format for creating an offline build mirror, which answers some of those questions about, will it be around for many years in the future? Can you work offline? Network access is performed only when explicitly enabled, which is now enforced. Network access works with the standard Linux proxy variables, so we can support various corporate environments that have firewalls and VPNs and different things. And that during parsing, network access is limited and only when explicitly enabled. So, either auto rev or it's hitting to check the revision or a tag, but it's not cloning entire source trees and checking them out to find information during parsing just to set a variable. Around the versions, revision information must be available during parsing, and that's for recipe version construction. Again, that goes back to, you can't really clone a whole source tree and check out an internal revision tracking file and get versions from that, because that's too heavy. It's too late for the revision information. The versions must increase in a sortable way for package feeds. And then the other ones were, of course, reproducibility. The fetcher output is deterministic. And then there was a desirable one, which is an API to query for possible upgrades to enable automatic code upgrade potential, which would be fantastic, which you see the patch series that come out once in a while for upgrades. It'd be nice if there was a way to integrate with something like that. And that, of course, for bitbake, you need self-tests for the functionality and the maintenance of the fetcher. Because we often get one person that understands the complexities of these languages, manages to implement a fetcher, and then it's merged, and then we have no way to ever maintain it or know it works ever again until it breaks, and then we still don't know how to fix it. So, and of course, not all fetchers support all of those features. They don't make sense, but that does not invalidate the guidelines, and exceptions to them can be discussed and agreed upon. Geez, I might make it to the half hour after all. I'm talking slowly. The challenges around these solutions is, of course, balancing those competing requirements, right? Developers versus integrators versus system build versus, you name it. Do you want simple recipes and complex fetchers, or do you want complex recipes and the well-tested fetchers, right? Long-term maintenance versus bleeding edge, generated information in the data store or wherever in a variable versus explicit static information. Do we want loosely integrated tools around the language fetch support, or do we want tightly integrated tools? Because you may have other modes and other use cases that don't involve a full build. Build performance versus reuse. Build performance and reuse of the components versus fine-grained dependency management. And so the big thing is, of course, we don't want to reinvent what the languages are doing. But the opposite of that is we also don't want the language fetchers to re-implement what bitbake and open embedded does, right? So, we were here first. We want to do it our way. But the point is valid that we don't need either re-engineering the other. And that while the challenge is that while the approaches are similar between the languages, the implementations are quite different. Meaning it's got file X that tracks the dependencies, or shrink wrap foo that does this, but the format's different, and the proxy and the way their variables that are different. So the implementation is quite different. So it's a challenge to reuse some of the things between the languages. And I say maybe that's a reason to expose some of the revision control systems that inevitably are out there that they're fetching from. And of course, the downloads, unpack, they do use standard tools, wget, git, svn, etc. So there's some reuse potential there as well. So for the types of solution, in my opinion, is flexibility is important. We need to support the different approaches without being too prescriptive, because having a magic tool, there is no magic, that generates you a recipe without the ability to tweak that recipe easily, or it hides a lot of information somewhere else that you don't know when you run the tool. It's difficult. It will inevitably not work for all these different corner cases, and then we're back in the situation of just doing recipes by hand, which is of course what I do, but that's a different story. And again, there's the dynamic versus static information, meaning do we have classes and inline Python and different things as part of the build that are going out and querying these files and generating bits of the source URI, or generating this and generating that and putting them into the data store, so then the recipe builds, and versus just listing it statically in the recipe. And that gives us, there's pros and cons to either way to do it. So, we can generate, recipes. Do we generate the data? Do we generate the configuration? Or, is it dynamically figured out during the build? Some examples in the ecosystem are, of course, npm shrink wrap, which is a nice example in the sense that the npm shrink wrap basically maps eventually down to the npm fetcher. I'm not a node npm guy, so don't ask me any details. I read the bitbake fetcher for it in preparation for this talk, but that's the extent of Rust, is another example in the ecosystem where you have the crate fetcher, and then there's the interesting example of meta-Rust and cargo bitbake, which is a tool that generates the crate information, which is of course just what the more basic crate fetcher uses. So you can see how these two things are hitting some of the items that were on my challenges, the list of challenges. Go, it is changed a lot over time, the way it has managed its dependencies. In particular, there was no vendor trees. Things were fetched and managed differently. Now that all the projects, they went through a phase of these giant vendor directories. Then with the newer versions of Go, that's been sort of depreciated, but we can still use it and generate it as long as we do it carefully. But I hope maybe they finally reach their final stable approach, which would be nice, so all the recipes don't break every Go upgrade. Python, where's Tim? I hope he's listening. It's largely avoided, but in my opinion, the requirements on if you have a project, in Python we package all the Python libraries. They're separate packages and they're just listed as dependencies. But because we don't have as fine-grained dependency specification, it's been avoided. But if you have a whole bunch of different packages that depend on very specific versions of the dependencies, you can run into a similar problem to what we see with some of these other fetchers and how they have to set up their build directory. And then Ruby, I know nothing about Ruby, but I think gems are the same. Another example in a similar problem. So onto the specific language example, Go. And that's one that I grudgingly, unluckily, run into in my maintenance of meta-virtualization. There's a large number of very huge Go applications in the cloud native world. And so the dependency management has changed a few times, everything from where the source is structured to what the variables are called to how it's fetched to vendoring to not. Like I mentioned, it's changed a lot over time. And of course, there's now in the recent incantations, there's proxy golang.org, some that golang, these held up infrastructure, right? It's like, will they be around in 10 or 20 years? I don't know. Maybe so. I've never researched to see what Google says about these sort of things, and because this is where some of the magic happens in the background when you do your Go gets and your Go vendor and these different things, as they're going out and hitting these specific sites to find the information. And the question is, should we set up a parallel and hosted infrastructure for Go mod based builds? So if we're really worried about that, or whatever the answer may be to that question. The question around the Go recipes is there's been various proposals on the OE architecture list. The most recently one, as it came out, we discussed it, I don't know, last fall, again in January, and then a RFC implementation came out while I was pulling together this presentation. And the various proposals have been either to generate the recipes versus the data during the build, which I already talked about. And then, what level of integration with BitBake, what stack of classes do they have to implement it? Does it work with the different tools, that sort of thing. So the proposals have been all over the place in the sense of hitting different balances between the challenges that I was talking about. The Go recipes, if you were to look at the dependencies and package them or worry about them individually, you can easily come up with hundreds or even thousands, and it's the same concern I've seen mentioned about NPM. And again, around Go recipes, source URI, it's like, do you want to explicitly list the source dependencies, or do you want to reference Go mod, Go sum? There's advantage to both, because we have a fetcher that already understands how to fetch these things. We know what source URI and source refs are. Or do you want to learn how to read go.mod and go.sum, which are specified, but it's a bit, their version specification is a little bit different than what we do. Do you want to have a vendored build which is populated by Go or the fetcher, or not? That would be, so the non-vendored Go mod build would be, rather than fetching and populating a vendor directory, we could set up an environment that would allow in the fetch phase Go mod to run, but only hit local. And I mean by local, I mean your build machine's infrastructure and source organization to find the dependencies and clone them into and move them into the build. And I would note that, if we do it right, you can do any of these implementations and they can all sort of coexist. You don't have to force every Go recipe to look the same. All depends on who's maintaining it in the end. All right, I'm almost done. My example I have is meta-virtualization in Go. I mentioned we have a lot of very large Go projects. Vendoring was common. It's not so common now. Kubernetes still does it. K3s doesn't. There you go. How's that for inconsistent? When I was trying to up-rev K3s, I ended up with 515 source dependencies. Some might not be required because, unfortunately, with Go versions, there's actually indirect dependency problems, and you can not find all the dependencies or find too many. So anyway, So there's 515 source dependencies. The recipe, source URI, and vendor creation, I generated them through an external script, and then it just uses the existing Git fetcher infrastructure during build. So, and then it's done. So you have a complex recipe with a big source URI and no fetcher re-implementation to worry about. When I did nerd control, it only had 153 source dependencies. And you actually will watch K3s fetch for a very long time and unpack for a very long time because of those amount of dependencies. I've now upgraded those through a few versions, so the approach works, but there's always room for improvement. But luckily, it can just sit and be while we work on the other details. So to finish up, for future work, of course, it's look for common points between the languages. It'd be great not to re-implement everything between the languages. Figure out what that core functionality is, leaving flexibility for the recipes. We need tests and documentation for them all, and be able to adapt to the inevitable corner cases and language evolution when they change their mind next year, and address long-term support and reproducibility concerns. And then there's lots of other future work, but those are the questions that came to mind while I was working through the presentation.